If we're looking at the question, so an arena has to have a ground area of 1,000 square metres and it's got to be rectangular shape. The owner wishes to minimise the cost of the fencing to enclose the arena. Alright, so if X is the length of one side, find the length of the other side. Now, what you'll find with these questions is they are problem solving questions and they give you enough information to do the next bit. Alright, so if we are told something about the area, what do we know? Alright, so let's do part A. Alright, so part A says we need to find what? So you're just answering the questions. If X is equal to that, find the length of the other side. So what we're going to say for that is, part A, is we know that the area is equal to what? 1,000. Alright, and we know the area is equal to the length times by the breadth. In this particular case, if we call that side over there X, we know that side maybe is Y. We could say that's equal to XY. And so therefore, we know that 1,000 equals XY. We know one of the sides is equal to X, so therefore Y, the other side, has to be equal to 1,000 divided by X. So you're finding the other side in terms of X. Now you don't have to call it Y. So what I could say is over here, this is actually X. The other side over there is in fact 1,000 divided by X. Okay, got the idea? Now the next part of the question says if P is the perimeter of the arena, show that P is equal to 2X plus 2,000 divided by X. Now why would I do that? Why would I give you the answer? The question I give you the answer is, if you couldn't do the first part, part A, then you know what the answer of part B is, so you can actually do the rest of the question. So the rest of the question requires you to use technology. So let's do that. Anyway, we have to show, keeping in mind we know what the answer is. So the perimeter is equal to 2x plus 2 lots of y. Obviously this is a pretty simple example. So 2x, where do we know y is equal to? 1,000 over x. Here we've done similar things to this. It's not like it's brand new. So that's equal to 2x plus 2,000 over x. Alright, so that's my perimeter. Now what are we trying to do? We're trying to maximise or minimise the perimeter. We're actually trying to minimise it so this guy doesn't have to build, use as much fencing, because the fencing might be quite expensive. Okay, so use technology to help sketch a graph of y versus that. So we could say there, perimeter if we really wanted to. So we'll put that into our calculator. So go to our function y equals, and we'll just clear that. So that's going to be 2x plus 2,000 divided by x. And then graph it. And you find, oh, I don't get anything. So you go, oh, my calculator's broken. Or I just crap on my calculator, sucks, I hate it. Don't do that. Now you've got two options. The first option is you can go to zoom and scroll down to 0, which is the zoom fit. What that will do is give you something to do with your graph. So if you can press 0, it will sort of scale your thing. Okay, so what have we got here? This function, did I put the right function in? I don't think I did I? Okay, so what are we trying to do? If I go back to my question, this is what you do, I know what I'm expecting to see. Right. No, I did that right, didn't I? So that was my function I'm actually looking at there. Alright, so what I'm really interested in, when I graph that, I'm really interested in this bit over here. Alright, so what I might do is zoom in on that section over there, so I can go from minus 10 to 10, I can go from, say, minus 5, and then go maybe up to 1,000 instead of 9,000. And graph that, might get a better, I don't really need to go minus 10 there. So let's go from -1, so we see our axes, and let's go up to say 100. Okay, and then we'll graph that. So what I'm expecting, because I'm looking to minimize or maximize, I'm looking for a graph that has that shape, aren't I? So what is it asking me to do? The question said, in that question says, use technology to help sketch the graph of that function. So what I'm going to do is I'm going to go, see, here's my graph. All right, I'm going to draw my axes. I'm going to do my shape over here for my graph. I'm going to label my values. That's going to be my P value. That's going to be my X value. That's roughly going to be 100. And what do we go up to? That's roughly 1,000, isn't it? And that's obviously the origin back down the bottom there. So I'm doing a sketch of it. That's what I'm doing. It's a sketch of my graph. If it says draw, then you're expected to draw that in a bit of detail. All right, so that's what I'm expecting there. Don't have to keep notes of this because I'm going to post this on the Edmodo for you. So the next bit says, using technology, find the maximum length of the fencing required, the minimum length of the fencing required to the corresponding value of X, and then the last bit would be sketch our optimal solution. So we're just going through the parts of the question. So we're going to do part D next. I know on my calculator I can find the minimal value there. Okay, the easiest way to do that is to go calc, all right, and go down to the min, so number 3, all right, scroll to some point on this side over here. Now, I could type in, say, 10, because I reckon 10's on that side over there. And then I could type maybe 80 for my right point rather than using my sketchy thing. Enter. That's a point. So I'm saying my min, somewhere between those values. I don't want to make a guess. And it will find that value. So it's saying X is equal to 31.62. And that gives you the area of that particular pitch. All right, so 31.62 is what I need to remember. And you can even label that point over here on your graph. That's 31.62 and 126 something. I won't worry about going back to it, but that, you can label that exactly. So using my technology, what am I going to do? I'm going to find my X value. So I'm saying X is in fact 31.62, right, for a minimum. I can't spell minimum. Min. I should know how to spell. I do know how to spell. Okay, for a min of 126 meters. All right, so you can say that. Then what I'm doing for part E, I'm actually doing the shape of the optimal box. Now, I need to work out what Y is. Y is equal to 1,000 divided by X. So that's equal to 1,000 divided by 31.62. And so I'm not even going to work that out because I know it's 3162. Okay, the minimal shape for most shapes is either things like circles or squares. Okay, and in fact that value there is really 4 times by 31.62 will give you 126 roughly. So my optimal shape here for my minimum thing, my minimum pitch, is going to be a square which is 31.62 meters by 31.62. Now I don't even need to label the other side because I've just shown it's a square, haven't I? By putting those two lines there. Now, is that an appropriate shape for maybe a spawning arena? Possibly not. Depends what it is. Now, 31 points, that's not a very big pitch, is it? No. Okay, so you might need to, so it has to be 100 metres by, say, 50 metres or 30 metres. So in reality, even though you've got an answer here which has got an optimal solution, it might not be the best solution for that. All right, so get the idea. We haven't really done with this question. We haven't really had to do anything but just do a little bit of algebra and then use our calculator. And a lot of these questions are exactly the same. Get your equation you want to maximise or minimise, and then when you've got that, you put into your calculator, you graph it, and you find your max or your min value. All right. So I'll just stop that, and that's the first video on our thing. So